Hi guys, welcome back to the channel. Now we'll be discussing the bi-weekly contest where we have the last question, which is maximum. Find the maximum sum of node values which is present in the undirected tree. So here we are given n nodes, and then we are given edges which contains the ui edge, ui node, and then there will be vi node, and then there will be like nums of I, which will represent the value of the node numbered at I, and then we need to, Bogdan wants the sum of values that needs to be maximum. So we need to make sure that the values of the nodes becomes the maximum. The sum of the values of the nodes becomes maximum. So for that we are given one more operation is like we can pick any edge which is present, and then we can make XOR of this particular nums of value with k, and then we can make any number of operations we can, and then we need to make sure that the sum of the values which is present in this particular tree is going to be maximum. So that's what we are going to solve. So let's take one particular example and then think what should be our intuition to solve. So let's take this particular tree. So it contains, let's take one more tree. So let's take one, let's take three, let's take three, and then four, five, and then six, and then seven. So let's take this particular where this is not the node number. This is the value which is present in this particular node. Now for this particular tree, let's say k equal to sum 5. Let's think like we can modify any number of times for this particular nodes. So if we want to modify any node, then if we get num XOR k, let's use keyboard instead. So num XOR k is greater than num, then we can say, then we can change, then we can change. That's what we are going to do, right? If it is greater only, we should change num to num XOR k, right? And then let's store the number of changes required for all of this. And then let's say if it is even, and if it is odd. So let's come to this, and then let's find out the number of changes which are required for all the nodes, and then let's figure out like if it is even, what will be the solution. So let's think. So this is this particular node you need to change, and then this particular node you need to change. So how can we change this? Yeah, we can do the operation between this and then this. If we do the operation between this and this gets changed to C, and then this gets changed to C, and then this will be like same. And then let's say again apply XOR on this one, this becomes same. Why? Because XOR of XOR will be like same element, and then this changes to C, this changes to num XOR k. So that will be like, it will be like a chain. If we change this particular case and then this again, C means changed. If it is yes, then it is the same number. So if we change this particular case, it becomes same again, and then this will be changed to C. And then again if we apply again here, it becomes yes, and then again it becomes C. So whenever it is even, we can say that we can change directly, and then we'll get to any node via chain. So for this particular case, we can change all the nodes whichever are required, and then we are going to use that particular value, which is maximum of num or num XOR k. So we are going to do that. Suppose let's say it is odd. Let's say we want to change only one element, only one element, and then to change only one element, let's suppose apply change on this particular nodes, then this becomes change, and then this becomes change. But we don't want this. Why? Because nums will be greater than num XOR k. So if we use num XOR k, then we'll lose some value, lose. So that particular lose, and then this will be increased. Why? Because we want change here, this will be increased, and then there might be loose for this as well if we change. So out of these two loose, so what will be the loose which we want to use? It should be like minimum, right? So we are going to pick the minimum which is the difference between those particular nodes. Yeah, let's see the solution so that we will understand better. So this will be the solution where it contains the total sum and then number of changes which are required, and then this is the difference we are going to store, like nums of I and then nums of XOR k. And then for this particular nums, we are going to say total sum plus equal to whatever the maximum value which we can have for this particular node, we are going to store that in the total sum, and then number of changes will be like incremented. Like if it is greater than nums XOR k is greater than num, then we can say that number of changes is added, and then we are going to say the difference between this particular num XOR k and then num. This difference we are going to store. Why? Because let's say num is 1 and then num XOR k is 10. So that is the difference between these two is 9. Let's say one more case, we have 100 and then nums or k is 101. So the difference between that is only 1. So if we decrease that, that is not a problem. But if we try to decrease from 9 to 1, then we are going to lose 9 sum. So that will not be optimal way. So we are going to say what is the what is the minimum difference which we can remove. So that is going to be stored in this particular difference. And then at last we are going to check if the number of changes is even. If the number of changes is even, then we are going to remove only 0. That means we are not removing anything. If it is odd, then we are going to remove the least difference which is present in this particular case. So we'll be doing that, and then out of this particular sum. So this will be storing the maximum. So out of that maximum, we might need to change. If we change only, we'll get the total sum. But if it is odd number of changes, then it is not possible. Why? Because it is a edge. We are doing operations on two vertices. So if we do the operations on two vertices, it will always be even. So if we apply the change, then one must change and then other should also change. So out of all those changes, whichever the minimum difference which is present, we are going to use that, and then we are going to remove that particular case. Yeah, that's all for this video. Thanks for watching the video.